So now that we've looked at the different shifts for functions, we can do other things as well, other transformations. So the telekinesis part 2 is going to involve flips and stretches and shrinks. So let's take a look. Our original function is still going to be our x squared, so we're very familiar with that. Now, what we're going to be doing with the second function is we're going to take the negative of that and see what happens. The third function, we're going to triple everything. We're going to multiply everything by 3. And finally, we're going to multiply everything by a third. So let's go back, and as before, I've created the table of values already. I'm going to grab that and put it in here. Okay. All right. So let's take a look. All right. So if we're looking at what is happening with each one of these functions, we're already quite familiar with the x squared, right? So it's 0, 0, and then it's symmetrical in either direction. But what's happening with the negative x squared? We still have 0, 0, and we're still symmetrical. But what happens? Instead of going 1, 4, 9, it goes minus 1, minus 4, minus 9. So it actually seems to be going down instead of up. So it seems to be looking like this instead of like this. That's very interesting. So then, and we'll confirm that or see what that looks like on the graphs. Now with the 3x, we're still at 0, 0. There's no shift. And we still have a pattern, 3, 12, 17, 3, 12, 3, 12, 27, 3, 12, 27. But now this pattern goes up a lot faster. So instead of looking the way that our x squared usually looks like, what we're doing is we're actually stretching it. We're stretching it this way. It goes a lot faster, right? We're taking the value and we're pulling it up. Okay, and maybe we can just look at it as pulling it up. Okay. Now, if we're looking at 1/3 x squared, we still have the 0, 0, and we still have a certain pattern going up and down. But now, instead of going 1, 4, 9, it's now going 1/3, 1 1/3, and 3. So it's actually it's taking much longer to get to where it needs to go. So it's actually being squished down. Now, a lot of the textbooks will tell you that this s of x, right, 3x squared, is going to stretch it vertically, and 1/3 x squared is going to stretch it horizontally. But if you look at this, it's still the coefficient of the value of the function. It's the coefficient of the y value. So what we're actually doing, whatever we're doing with that coefficient, with that number, is happening to the y-axis. We're not doing anything horizontally. We're doing it vertically. So either in the first case, we stretch it. When we're multiplying by a large number, we stretch it. When we multiply by a number less than 1, we shrink it. We squeeze it from top and bottom. So I'm going to let you write this out as you describe how these different operations are impacting the value of the function of the squaring function. All right, then we're going to look at the graphs. And again, I've prepared the graphs. Let's grab those. Put them in here. Okay. So let's see. We have the x squared, our regular function that we're very familiar with by now. And notice there's been no shifts. They're all starting at 0, 0. We haven't shifted left or right or up or down. What we have done, though, is we have flipped. Right? That's that negative x squared. So instead of having a 1, 1, we have a negative we have a negative 1, 1. And I'm just going to do a different color. Negative 1. 1, negative 1. And instead of having a 2, 4, we're going to have 2, negative 4. And same thing here. Okay, so what we've done is we flipped everything. All right, you see it? So instead of a positive, it now is a negative. Okay, let's look at the next one. All right, so the next one we did was 3x squared. So notice here that instead of 1, 1, we now have a 1, 3. We have a 1, 3. Instead of having a 2, 4, we have a 2 way over there. It's going to be a 12. Same thing here. So what we've done is we have stretched that distance 3 times. Right? So every distance of 1 is now a distance of 3. And finally, let's take a look at this 1/3 x squared. Okay, well, instead of our 1, 1, we now have a 1, 1/3. Instead of a 2, 4, we now have 2, 1 and a third. So notice that what's happened is now we've shrunk the y-axis, the y values, from 4 to a third of that. Right? So what I'd like you to do is take a look and describe how these graphs, what the graphs show about the properties of these coefficients. And finally, I'd like you to graph minus -2 f of x and then -1. So each one of these numbers is going to have its own behavior. The minus is going to flip down. The 2, right, is going to stretch vertically, the y-axis, and the -1 is going to shift down. So try to graph, you can use the table of values or try to graph that function and see if you can identify each one of these transformations. Okay. So finally, let's take a look at these transformations and see if we can figure out some of the what we're doing to that f of x. Remember, it's that same strange f of x, right? It has that 0, 0 and a -1, 1. And let's see if we can figure out what's happening with these shifts or these stretches. So let's look at A. So what do you notice with A? It's still at 0, 0. But do you notice that it got skinnier up here? So instead of at -1, 1, this distance got stretched. How much? Got stretched threefold. So it actually got multiplied by 3. Okay. How about B? B has the same 0, 0, nothing shifted, but now it's facing down, right? But the values are exactly the same as they were in f of x. So this is the negative. Whatever the function is, it's the negative f of x. And finally, C. Well, what happened to C? In C, we've shifted it left, which means that whatever the values were, whenever it was 0 was, for example, whenever it was 0, it now needs to be at -2. X is -2. And also, we need to flip it, right? Because it's also now facing down. Everything that was positive is now negative. Okay. So let's take a look at these now. Our f of x is given. What does D look like? The negative f of x. So D is going to have all of the positive values are going to be now negative values. So they're all going to be negative values. Okay. So that's going to be D. Now E is going to be, it's still going to be positive values, the way that F was. But now instead of F being 1, F is going to be 4. So at this point, instead of being 1, it's going to be 4. And at this point, it's going to be. So drawing it, we're going to need to really squeeze it super tight. And then squeeze it super tight. So that's going to be E. Because it's going to stretch this distance. Instead of being 1, it's now going to be 4. All right, how about F? Half. So instead of the value being 1, it's now going to be half. Instead of being 1 here, it's going to be half here. So it's going to look, instead of being 4 there, it's going to be 2. It's going to look similar in shape, but flatter. Okay, by about half. So that would be F. And finally, G. Let's see, G. Oh my goodness. It's going to be negative. It's going to stretch the distances, the y-axis, by 2. And it's going to shift things down by 3. So it's going to be negative, just like D. That's going to be shifted down by 3. Down 3 points. And then instead of coming down to here, it's going to stretch every distance. Make it double. Okay, so that's going to be G. All right. So do you notice that every one of these values has a meaning? So this is flip down. This is stretch 2 times this way. And this is down 3. Okay. So every single thing in that equation has a certain impact on the graph. So, and it's important for us to be able to understand what these different symbols in our algebraic expressions, how they impact the table and how they impact the graph.